Synthetic division of polynomials. In this section, what we're going to do is we're going to learn a quicker way to divide polynomials. Now, it is really nice. It goes really short. It takes up way less more space than long division does, but it only works in certain situations. When does synthetic work? It only works when you are dividing by factors like x minus a or x plus a. It only works when you're dividing by these linear factors. And so what we're going to do is we're going to work with these factors. If we were to take these and set these equal to 0, we would be able to see what the zeros are, which would be x equal to positive a or x equal to negative a corresponding. So we're going to use the fact of what the zeros are in order to work this division. We'll go pretty slow with the first couple of examples, and then you'll see that we're going to speed up as we go. So the first thing that you do is synthetic division, and really, you're going to love this process. You take your division bar. Typically we have it like this. We're going to flip it upside down. Next thing that you're going to do, similar rules to long division, you do have to put them in descending order, but we're going to be kind of lazy with this process. We are going to only put in the coefficients. So that means I'm only going to use 6, negative 19, 16, and negative 4. But again, let's add this into our notes. Note, two things have to happen. You do have to check for any missing degrees or terms. And number 2, you have to put them in descending order. Now, when we were working with long division, it was more of an organizational tool. And synthetic, it is a requirement. If you don't have these two things, what you're working with are not going to be correct. Now, we're only going to put our coefficients in this division bar. So I'm going to put 6, negative 19, 16, and negative 4. And you do have to keep those negatives with the numbers. Now, what goes out front? Now, typically, your x minus 2 would go out front. But again, we're not putting x's in any of this. So what you're going to do is you're going to take your x minus 2 and you're going to set it equal to 0 and solve. So x minus 2 equal to 0. That gives me x to be positive 2. So positive 2 is what goes out front. If you mess up that positive or negative in front number, everything else is going to domino out of control. Next thing we're going to do, the first thing you do in this process is you bring down the 6. So I always put an arrow right here, because if I don't put an arrow, I might put a number right there. So I'm going to bring down that 6. Then you always multiply by the number that's out front. So I'm going to multiply this 2 and 6 together. It gives me 12, and I place it in this next spot. Then you're going to add vertically the negative 19 and 12 together. That gives you negative 7. So you can see once I multiply the 2 times 6, I place the number here, and then I add it vertically. So now I'm going to do the same thing. I'm going to multiply this 2 times negative 7. That gives me negative 14. I put it in that next spot. Then I add vertically, so I'm going to take 16 and negative 4, add that together to give me a positive 2. Multiply 2 times 2, that gives me 4. And then I'm going to add vertically, which gives me 0. Now, this process does go very quickly, and maybe you're still a little bit confused. We're going to work quite a few examples so you can see these processes as it plays out. Now, all this is numbers. There's no letters in here. So what is our result? Well, this started out as an x cubed. Dividing by a linear is going to drop this by 1 degree to an x squared. So this is our x, this is our constant, and this would be our remainder. So what was the result of dividing this? 6x squared minus 7x plus 2. And that would be my answer. So let's look at another problem and kind of go through this process again and make sure we have all the pieces in play before we start applying it even more. So the first thing you're going to do is you're going to set up your division, and it's just like flipping over that long division sign. Next thing you're going to do is you're going to write your coefficients of the polynomial in descending order and checking for the missing degree, just like what we wrote up here. So we're going to say, okay, x to the fourth is the largest. There's an assumed 1 there, so I'll say 1. I do not have an x cubed. Here, let's zoom in a little bit. I do not have an x cubed, so I'll put a 0. What is my x squared? I have an x squared of negative 10. Again, just keeping negatives and positives, but not writing any letters in this process. Negative 2, and then positive 4. Then what I'm going to do is I'm going to take this x plus 3 and I'm going to set it equal to 0. That gives me x equal to negative 3. This is the value that I'll put out front. Again, we don't use any letters. Now, when you start your process, the first thing you want to do is you want to bring the 1 down. And again, I always put an arrow right there so I don't accidentally put a number there. Then you're going to multiply. So you're multiplying these two pieces together. Once you multiply these two pieces together, negative 3 times 1, that gives you negative 3. You put it into that next spot available. So I'm going to place it here. Then you add vertically. So I'm going to be adding these two pieces, negative 3. Then I'm going to multiply negative 3 times negative 3, and I'm going to put the result in this next spot. So I would say, okay, negative 3 times negative 3 gives me a positive 9. By all means, use your on-screen calculator to assist you with these small arithmetic pieces so you don't mess up a number. Then you're going to add vertically, which gives me a negative 1. You're going to multiply negative 3 times negative 1. That gives me a positive 3. You're going to add vertically, giving you a positive 1. Multiply negative 3 times 1. We're almost done. That gives me negative 3. And then add vertically to give me 1. Now, this is very much a shorthand, but you can see it goes a lot quicker. It takes up a lot less space on your paper. But what are we left with? Well, we started with an x to the fourth. We're dividing by a linear function, so it's going to reduce by 1. So this gives me an x cubed, x squared. You just start writing this in order. X, this is your constant, and then this is your remainder. So the result of dividing this is x cubed minus 3x squared minus x plus 1 over what I was dividing by. Another one now. This says divide 3x cubed plus 8x squared plus 5x minus 7 by x equal to negative 2. So the first thing we're going to do, like the last two, is we're going to flip our long division bar upside down. We're going to write in our coefficients of our polynomial. So I have a 3, 8, 5, and negative 7. I'm just pulling these numbers here in descending order of exponents. Then this already has x equal to a number, so I'm just going to put the negative 2 out front. I don't have to manipulate or solve that around. First step, you're going to bring the 3 down and place it here. Next, you're going to multiply negative 2 times positive 3, and you'll place that number here. So it gives me negative 6. And then add vertically, which gives me positive 2. Multiply negative 2 by positive 2, that gives me negative 4. Add vertically, it gives me positive 1. Multiply negative 2 times positive 1, that gives me a negative 2. And then add vertically, which gives me a negative 9. This right here is my remainder. Remember, when you're dividing, this start out as an x cubed, so it's going to reduce by 1. That gives me x squared. X, this is my constant, and then my remainder. So the answer would be 3x squared plus 2x plus 1 plus negative 9 over, I was dividing by an x plus 2. Now, in order to get that x plus 2, I can come over here and add that 2 back over. So this would be my factor, but the 0 is what I'm putting out front when I do synthetic. And so you can see synthetic goes really nicely, but it does only work with linear pieces that we're dividing by. Now, there are other results that come out of synthetic division, and the first result that comes out of that is called the remainder theorem. The remainder theorem says that, let's look at this. From our previous example, that problem that we last did, we had 3x cubed plus 8x squared plus 5x minus 7. The remainder theorem says this, that whatever you divide by, the remainder is what you would get if you would evaluate. Let me write that out. If you have f of x equal to 3x cubed plus 8x squared plus 5x minus 2, and you want it to evaluate at f of negative 2, that was from our previous example, that f of negative 2, notice, when I plug negative 2 in for x, just quickly doing this, let's see, that would give me negative 3 times negative 8, 8 times negative 4, minus 10, minus 7, just cleaning this up. I could use my on-screen calculator too. All that together gives me negative 9. And isn't that interesting or a coincidence that that negative 9 that we got was the remainder? So I don't think that's a coincidence. So you can see that now, if I find, say, f of 4, I can do that by using the remainder theorem. Instead of plugging and chugging through all those calculations like we did on the last one, I can put 4 out front, work through my synthetic, which we've seen that as we work through that, that goes very quickly. Now, you might have to use your calculator a little bit because these numbers are getting larger. But I can grab 333, and notice I could check this, and I could say, okay, well, what was f of 4? Again, plugging it in, I have 3 times 4 cubed plus 8 times 4 squared plus 5 times 4 minus 7, and that is also 333. So just an interesting thing that the remainder that you get when you work through your synthetic is the same value that you get when you evaluate. Now, synthetic has a place in time because not only does it long divide, not only does it help us with this idea of a remainder theorem, but it actually is going to really help us in some of these next problems. And so what we're going to be looking at is finding the zeros and the complete factorization. So we don't want to just stop on a base level of knowledge and go, I can divide. I want to take this, amp this up and go, you know what? I want to be able to use my division skills, and synthetic's going to help us with that in order to find all the zeros of these larger functions and the complete factorization of these larger functions. Like, what pieces did it come from and get multiplied together? And when we talk complete factorization, we're talking about finding all the linear factors, like all those pieces that were multiplied together initially to give us that really long equation. So let's look at this example here. It says find all the zeros of x cubed minus 7x plus 6 equal to 0 that has a factor of x minus 2. So if it tells you, let's look for keywords here. If it tells you that it has a factor of x minus 2, that means that your remainder, when you go and you divide this out, better be 0. It is a piece of the original multiplication, so it's going to divide really nicely. And so I would take x minus 2, set it equal to 0. So I get a 0 at 2, and that's what's put out front. I'm going to place my coefficients. There's an assumed 1 here. I do not have an x squared, so I need to make sure I put a 0 as a placeholder. Negative 7 and 6. I'm going to work through my synthetic, so I'll bring the 1 down, multiply, add, multiply, add, multiply, add. And again, because of that fact right there, that it was a factor, I better get 0 as a remainder. This originally was an x cubed, so now I have x squared, x, this is my constant. So if I take my result, x squared plus 2x minus 3, I can now, once I get it down to that quadratic form, now let's factor this into linear factors. Well, that factors 2 parentheses, x times x will give me x squared, a positive 3 and negative 1 that will multiply to give me negative 3 and add to give me positive 2. So the question asks, what is the complete factorization? It would be the x minus 2 they originally gave me. Now I have x plus 3 and x minus 1. So that's your complete factorization. And if it says, what are all the zeros? Well, we first got the 0 of 2. And then you can just take these and set them equal to 0, which is going to give you the negative 3 and positive 1. And so you can see synthetic really helped us because we were working with a cubic function. We took a known factor or 0, we removed it, we were left with a quadratic, and from our previous knowledge of solving quadratics, we're able to get that complete factorization. So if I were to check this answer, what I could do is I could fully multiply this out by foiling, distributing, and I would get back to this original solution that I was working with. And that's where synthetic is really going to aid us in taking this not from just going, oh, I can divide, but giving us a tool in order to break down some equations. I'm not going to leave you with just one example. Let's do another one. This one says, find all the zeros of 3x cubed plus 2x squared minus 19x plus 6 that has factors of x minus 2 and x plus 3. Again, these pieces that they're giving you are your jumping off points. It's the things that are going to tell you like, hey, these pieces work. So that's what you want to start with. And so we're going to say, okay, well, let's go ahead and set up our synthetic division. I'm going to go ahead and put in my coefficients of 3, 2, negative 19, and 6. I'm putting them in descending order of the exponents that were on their variable. And if there was one missing, I would have to put a 0, but there was not. And let's first start with x minus 2. Remember, when you're given a factor, you want to set it equal to 0 and solve. So I'm going to put a 2 here. And then I'm going to work through my synthetic division. So I'm going to bring down the 3, multiply, add, multiply, add, multiply, add. And again, you better get a remainder of 0 right there because it was known. Now, because they gave me another factor, I am going to start with this factor with my result. And so I'm going to take x plus 3. I'm going to set it equal to 0. That gives me negative 3. And then I'm going to continue this synthetic. So I'm just going to make another spot here. Now I'm going to take out negative 3. So I bring it down, multiply, add, multiply, add. And again, you better get a 0 as a remainder because we know it works. What's really nice about this process is we started out as a third degree. So this was our x cubed. We landed at a quadratic, and we could have stopped there and factored our quadratic formula, but they gave me that other factor that works, so I'm going to work with it. So that means I'm left at a linear factor down here. So this worked out really nicely just using what they gave me and my synthetic division. And so what is the complete factorization? The complete factorization of this is going to be x minus 2. That was a given. X plus 3. That was a given. And then this final result of 3x minus 1. Now, if they ask me, what are the zeros? Well, your zeros come from the fact of here and here, this 2 and negative 3, because they gave you a 0 on the remainder. So x is equal to 2. Negative 3, and then to find that last one, you're going to take this result here, 3x minus 1, and set it equal to 0. So that gives me 1/3 for that remaining 0. And so you can see synthetic division really helped us out in working through this. I want to do one more example, and I want to amp it up a little bit and go to a higher order. So it says, write the complete factorization of the polynomial and list all the zeros, knowing x minus 2 and x plus 3 are factors. So that is where I'm going to start with these known factors. So I'm going to set up my long division here, 2, 7, negative 4, negative 27, and negative 18. Let's start with the x minus 2 first. I'm going to set it equal to 0 to make sure I get my sign right. So I'm going to put a 2 here. Work through my synthetic, 2. Now maybe you need to pause right now and you work through the synthetic. Once you get done, hit play, pick up with us and see if you have it correct. 2 times 2 gives me 4. I'm going to add, multiply. Reminder, I'm just adding these two numbers together. And then I'm multiplying every time by that pivot out front. So that gives me 36. I'm not going to stress about how these numbers are going to come about. And then I get a 0 as a remainder. Now, if you don't get that 0 as a remainder and they told you it was a factor, definitely go back and check your work. Now, they gave me another factor, so I'm not going to go back to the original because my goal is to break this down fully. So I'm going to end with the result. And I'm going to take that x plus 3, set it equal to 0. Setting it equal to 0 helps you to get the right sign on your 3, hoping that it's, I got to make sure it's negative. And then I'm going to work my synthetic again. So I'm going to bring down the 2. I'm going to multiply, which gives me negative 6. Add, multiply, add, multiply, add. And again, you better get that 0 of the remainder because they told you it was a factor that works. Then let's look at what we have left. So we started out as an x to the 4th. We landed at an x cubed. We did it one more time, so that's an x squared. Here's our x, and here's our constant. So from this piece here, we can see we have 2x squared plus 5x plus 3. So that's my quadratic. So our goal was to get a complete factorization and list all the zeros. So I'm going to take this and say, well, I know x minus 2, I have my x plus 3, but now I have this 2x squared plus 5x plus 3. So what I have to do is take that, and I'm going to have to factor this out. So 2x squared plus 5x plus 3. Because I have this 2 in the front, I'm going to multiply those two pieces together. And that gives me a 6x squared. Think about all the factors that would give you 6x squared. Think about their combination that would add to give you the 5x, and I can split that. So 2x squared, that would be 2x plus 3x plus 3. Look at your front groupings. We can pull a 2x out. That gives me x plus 1. Look at your back groupings. You can pull a 3 out, which gives me an x plus 1. So that factors into 2x plus 3 times x plus 1. So you've definitely got to retain those skills from working with those quadratics. The complete factorization of this would then be 2x plus 3, x plus 1. So that's our complete factorization, taking it down to your linear terms. And then when you go into your zeros, we already know 2 and negative 3. You could just continue this work here and set these equal to 0. So that gives me x equal to negative 3 halves and x equal to negative 1. So look at the skill set that we've gotten to. We were able to take this 4th degree polynomial and break it down into the complete factorization of linear terms and find all of its zeros. And this is the work that would need to be shown for this problem in an exam situation. Go and try the homework for this section. Once you've worked through all those questions, reach out to your instructor for assistance.